Hello, everyone. Welcome to Alexa Live. My name is Justin Jeffress, and I'm an evangelist at Amazon, and I teach people how to build Alexa skills. And I'm very excited today to talk to you about Alexa Conversations, the future of voice user interfaces on Alexa. In this session, we're going to talk about how you can build better and stronger conversational interfaces faster with Alexa Conversations. I'm honored to share the virtual stage today with two of my esteemed colleagues, Nihal Belgamwar and Angeliki Metalanu. I'm also excited to share some demos and early impressions from our private beta participants, iRobot, Big Sky, and Arrive, to demonstrate the promise of Alexa Conversations. Before we talk about the future of voice, let's take a moment to review where we are today. Alexa was released in 2014, and since then we have seen over 100,000 skills released, reaching more than 100 million Alexa-enabled devices, and 4 out of 5 Alexa customers with Echo devices use skills. So there's lots of potential customers out there for you. There are hundreds of thousands of Alexa developers, just like you, building skills that are available in over 80 countries and 13 language variants. Skill builders are creating innovative experiences using Alexa's automatic speech recognition and natural language understanding technology to let people use their voices to interact with content, services, and devices. And when you think about experiences on Alexa, there's 2 big categories. The first is one-shot interactions. These are interactions where the user goes to Alexa and says, please do a thing, and Alexa does it. The user gives one command, which is interpreted and sent to the backend, and that backend does some work and sends back an I'm done confirmation. And the intent and utterance-based interaction model that converts what the user said into normalized data works really well for one-shot interactions. On the other hand, what we see a lot of innovation turning to in the next several years is around multi-turn interactions. And these are interactions where it's a turn-by-turn interaction between the customer and the skill. This dialog represents the happy path to provide a dog recommendation. The customer is asked a series of questions, and once all the necessary information has been provided, the skill makes a recommendation. And using an intent and utterance-based interaction model, one way to solve this is to create a set of intents and customer responses and map them to it. But what it doesn't show you is how to manage the state of the conversations. This is something that takes place in your backend code. To fully understand the complexity of designing for voice, let's zoom into our happy path. So here we've taken our happy path and we drew a box around each call and response pair. When our customer says something, our backend will need to determine what question to ask next. So let's take a closer look at turn number 3. In this case, our customer answered the question, do you prefer high energy or low energy dogs with their preference, which happens to be high energy. As a result, the skill moves to the next dialog state. So let's zoom out and see what it looks like when our customer follows our predetermined happy path script. Each blue dot represents the state of the conversation, and the arrow represents the intended direction. The wavy, navy, numbered blue arrow represents the actual path. In this case, our multi-turn interaction is linear. The case is incredibly easy to build an intent and utterance-based interaction. But what happens if our customer deviates from the happy path? You end up with something like this. In this case, our user may have said something like, I want a low energy dog. Actually, you know what? Make it high energy. And you know what? How many pounds is a large dog? You know what? Make it small. So as you can see, it's natural for conversations to deviate from a predetermined script. And in order to support these deviations, your skill must provide adequate front-end and back-end logic. On the front end, you need a robust set of utterances mapped to intents that accurately predict how the conversation may fall off the rails. Your back-end code needs to keep track of the dialogue state and determine what question to ask next based upon the environmental and conversational context. As you can see, developers have to write and maintain code for each possible permutation of how the user could interact with the skill. This leads to a brittle and limited experience. And now that we understand the problem, let's take a look at how Alexa Conversations helps us solve it. Alexa Conversations uses AI to analyze your happy path and to simulate the various ways that the conversation could deviate for you. And it also tracks the conversational context. And the goal of Alexa Conversations is to make customers have more natural, human-like conversations, and to reduce the code necessary for dialogue state management. And then also, we reduce the model training data. Alexa Conversations can be added to an existing skill, so you don't have to start over from the very beginning. You can add a new experience to your existing skills. So now that we understand the benefits of Alexa Conversations, I'm really excited because this is the first time that we're able to show to somebody outside of Amazon and our initial private beta preview participants a skill working with Alexa Conversations. So I'm going to turn it over to Nick Cuneo from iRobot, and he and his team are updating their existing Alexa skill with Conversations to build the future of voice user interfaces for robots. Take it away, Nick.
Thanks, Justin, for having me on today. I'm excited to be here to talk about voice, smart home, and robotics, and to show the world what we've been working on with Alexa Conversations for the first time. Hi, everyone. My name is Nick Cuneo, Principal Software Engineer at iRobot. At iRobot, we want to empower the user to do more as you bring our robots into your life and home to control them the way that you want to control them. One of our key initiatives is to build a best-in-class voice experience so that you can control the robot in new and interesting ways, especially in the moment. One of the challenges we faced with scheduling was to train the Alexa natural language model on all the different ways the user might say something to schedule the robot. Our first iteration of scheduling had hundreds of utterances, and when you take into consideration our localization needs for our Alexa users around the world, it became quite daunting. We chose to kind of build a wizard-like approach and ask for each piece of information one at a time. And it was really difficult for Alexa to understand open-ended questions like, do you want to clean the whole space or a specific room? So as part of our wizard, we ask the user a yes or no question. Do you want to clean the whole space? If they said no, we have to ask for each room one at a time. Alexa Conversations helps us bridge all these gaps and more with list support and dynamic entities. And so we're really excited about the possibilities it can bring us. If you've ever done scheduling before in any voice app, you probably know that the experience is not always natural and smooth, especially when you want to make a correction and end up just starting over. With Alexa Conversations, you can build skills with these natural common variations already built in. And so we've been working on extending our iRobot Home skill here at iRobot with Alexa Conversations so that you can have the power to make those changes and keep going. And so let's do a little quick demo and show you what we've been working on. So we have a new Roomba, Arnold, and Arnold needs a cleaning schedule apparently. So let's give it one. We're gonna do multiple days and one in vacation. And we're gonna show an instance where the user changes their mind about what time that they wanted to schedule cleaning. So let's see how Alexa Conversations handle these interpretations and see what happens. Alexa, ask iRobot Home to list my cleaning schedule.
Arnold does not have any scheduled cleaning jobs at this time.
Schedule vacuuming Monday, Wednesday, Saturday at noon.
Where would you like to schedule Arnold to vacuum?
In the office.
You want to schedule vacuuming the office with Arnold Monday, Wednesday, and Saturday at 12 p.m. Is that correct?
Actually, make that 9 a.m.
You want to schedule vacuuming the office with Arnold Monday, Wednesday, and Saturday at 9 a.m. Is that correct?
Yes.
Arnold is now scheduled to vacuum the office every Monday, Wednesday, and Saturday at 9 a.m.
Oh, also vacuum on Sunday.
You want to schedule vacuuming the office with Arnold Sunday at 9 a.m. Is that correct?
Yes.
Arnold is now scheduled to vacuum the office every Sunday at 9 a.m.
Easy as that, we're able to add Sunday too to the conversation. Alexa Conversations had the contextual awareness to remember what we were talking about and add it to the confirmation of the dialogue. That schedule is now available on both the robot and in the iRobot Home app. So as you can see, Alexa Conversation offers us better list support, dynamic entities, powerful voice models, contextual awareness. These are all things that we're really excited about at iRobot to kind of bring to our Alexa skill to empower you to do more. Now, on to Nihal to do a teardown of the skill to show you how we built this.
Thanks, Nick. Hi, I'm Nehal, a software development engineer at Alexa Conversations, and today I'll be talking about how to build a skill with Alexa Conversations. There are two ways developers can build an Alexa Conversation skill. The first is where Alexa Conversations is used as a default dialog manager. This means Alexa Conversations will control interaction for every dialog of your skill. The second is where Alexa Conversations is used as a dialog manager for a custom skill. This means Alexa Conversations will control interaction for a portion of your dialog in order to accomplish certain tasks like collecting data or providing offers and confirmations. As Justin mentioned previously, Alexa Conversations handles most of the state management for us by using AI-driven models. In order to achieve this, we need 5 different build-time components from the developers. So let's take a look at them. We are going to start by writing our sample dialog. You can think of a dialog as an example conversation that flows back and forth between user and Alexa. These dialogs stitch all the Alexa Conversations components together. The next component is utterance set. An utterance set covers all the utterance variations expected from the user for a specific turn within a dialog. Once we have our utterance sets, we are going to identify things that we need to collect, and these are called slots. Slots can be collected from the utterance sets and can be used in the next 2 components. Then we are going to define our APIs. API is how Alexa Conversations connects to your backend service in order to process your data. Now, your API can have arguments, which will be filled with the slots that we collected in the dialog so far, and will also return a slot. Alexa Conversations will predict the correct API based on the dialog context. Now, a single dialog can interact with 1 or more APIs, or you can have different dialogs interacting with different APIs in order to provide a more rich experience. Our last component is response templates. This is how Alexa Conversations takes information from both user and API and renders it back to the user through both audio and visual forms. It also supports variations to provide a more natural experience. Now that we have a high-level understanding of what these 5 build-time components are, let's take a closer look at each one of them. Let's start with the first component, dialogs. So here is a simplified dialog based on iRobot skill that Nick presented. So let's go through this dialog. User starts by saying, schedule cleaning for Wednesday. Alexa replies with, where would you like to schedule the cleaning? User says, in the kitchen. Alexa then confirms by asking, just to confirm you would like to schedule cleaning for Wednesday. Once the user says yes, Alexa says, confirmed. Max will clean the kitchen on Wednesday. Max is the robot name here. Once we have identified our dialog, we identify things we need to collect. And if you remember, these are called slots. We identify Wednesday, kitchen, and Max, which is the robot name, as the slots in this dialog. There are 2 types of slots. First is singular and second is compound. Singular slots represent a single value. For example, Wednesday is a singular slot of type day. Compound slots represent a set of slots, and this is generally returned by your API. For example, schedule cleaning result is a compound slot here, which has properties, day, location, and robot name. And you can think of these properties as slots themselves. Let's take a look at how all of this will be represented in the UI. When you build a conversation skill, you will find Alexa Conversations tab on your left. This is where you can create your sample dialog. Now, as you can see, I've already created our dialog, and I've also identified the slots that we need in order to call our API. So let's take a look at how we can define our singular slot type, location. As you can see, this is where we'll define our singular slot type location, which can take 3 values: location, living room, and kitchen. Let's take a look at how we can define our compound slot. Here we have schedule cleaning result slot type, and this is the object that will be returned by our API. In order to define the compound slot type, we have to add its properties along with the respective slot types. Now that we have identified our slots, let's move to the next component, which is utterance sets. The sample dialogues represent one possible way our user might respond. But what happens if they phrase it differently? Now, Alexa conversations will be able to handle most of these variations for us. However, there is a way for developers to explicitly provide these variations without having to write a new sample dialogue. And this can be done using utterance sets. For example, schedule cleaning for Wednesday can be said in various different ways, like set up a program to clean on Wednesday, or can you please ask the robot to clean on Wednesday? And all of these utterances will be grouped together into one utterance set. Once we have identified our utterance sets, we need some more information in order to understand what function each of these utterance sets serves in the dialogue. This can be done using dialog acts. A dialog act categorizes the action taking place at each line of the dialogue. So let's go through our dialogue and try to identify dialog acts for our user utterances. When user says schedule cleaning for Wednesday, it's the first time user conveys to Alexa that it wants to invoke schedule cleaning. Hence the dialog act here is invoke. Next, Alexa is going to request for location and user informs the location by saying in the kitchen. Hence the dialog act here is inform. Alexa then confirms if the user actually wants to create a schedule and the user affirms by saying yes. Hence the dialog act here is affirm. Now let's take a look at how we can define this in our UI. We can annotate our dialogue with utterance sets in two ways. First is selecting already created utterance set from the drop-down that appears on your right, or by creating a new utterance set on a new inline model that appears. After annotating utterance sets and dialog acts, we move to the next component, which is response templates. Alexa Conversations uses response templates to respond to user utterances. They can be used to collect more information from the user, like requesting location, or to take the response of an API and notify it back to the user. Response templates support API, which is Alexa presentation language, for multimodal experiences to render both audio and visual interfaces. Similar to how we identified user dialog acts, we also need to identify dialog acts for a system or Alexa responses. So let's do the same thing. Let's go to a sample dialog and try to identify dialog acts for our Alexa responses. When Alexa says, where would you like to schedule the cleaning, Alexa is requesting the user to provide the location. Hence the dialog act here is request. After user informs the location, Alexa confirms by asking, just to confirm you would like to schedule cleaning on Wednesday. Hence the dialog act here is confirm. Once the user affirms, Alexa will then notify the user that the schedule was created successfully. Hence the dialog act here is notify success. Now let's go back to our UI and see how we can define this. Similar to how we created utterance sets, we can also create response templates inline via this modal without having to leave our schedule cleaning dialog page. After we annotate our response templates, we also need to select the correct dialog act by selecting the dialog act from the drop-down that appears on the right. After we are done defining our response templates and dialog acts, we define our APIs. So this is how our API looks like. So we have the schedule cleaning API and we have a set of arguments that we define for this API. So as you can see, we have arguments state and location, which are required. What this means is Alexa Conversations will collect these arguments from the user before calling the API. And we also have robot name, which is an optional argument. This API returns schedule cleaning result, which is the compound slot that we had defined earlier, if you remember. Let's take a look at how we can define this in our developer console. So here is the modal where you will create your API reference. So you'll have to specify the name of your API and the arguments. There is a toggle to specify if the argument is required or optional. Now that we understand all these build-time components and what they do, we need to define the logic to fulfill the request for our API. And for those of you who have built a custom skill before, this must be familiar to you. So let's take a look at our request. So this is the JSON request. If you're familiar with Alexa skill, you must be used to the request type being either intent request or launch request. But as you can see, for an Alexa conversation skill, we got API.invoked. Remember, while defining our API, we defined it with the name schedule cleaning. If you check the property name here, it's pointing to the same API. And if you look at the properties of request entity, we have day and location, which are filled with kitchen, and Wednesday, which are the slots that we identified previously. Alexa Conversations also supports entity resolution. I did not include that object here because it was too big to fit on the screen. But as a part of this JSON request, you'll also get all the resolved entities. Now that we know what our request looks like, our skills encode should return a result based on this request. So let's take a look at what our result should look like. Remember when we defined our compound slot, schedule cleaning result, which are all of these properties that we wanted to return? This is what it will look like, and this is what will be returned back to Alexa Conversations. So we are done defining our built-in components and our skills encode. Let's take a look at how all of this ties together at runtime. When the user says schedule cleaning for Wednesday, Alexa recognizes that we got one of the two required slots. So we got Wednesday, which is day, but we did not get location. So it's going to request for location. Then once the user says in the kitchen, we have both the required slots. So Alexa Conversations at this point is going to confirm the API and its arguments. Once the user affirms by saying yes, Alexa Conversations will call the API. Your skills endpoint will receive the request that we saw earlier, and it will do what it needs to do and return the result back to Alexa Conversations. Alexa Conversations will take this response and render it back to the user through response templates. Now I've discussed various components of Alexa Conversations and how they work together. But what are the benefits that Alexa Conversations provides? The first benefit is state management. Alexa Conversations does most of the state management for us. As Justin mentioned earlier, developers are expected to provide a happy path of their dialog. And Alexa Conversations will take this dialog and add deviations. This way, users don't have to worry about all the possible combinations of deviations that can happen. The second is confirmations. Alexa Conversations allows us to confirm an API and its argument before calling the API. And we saw an example of this in the iRobot demo. Remember when Alexa said, "Are you sure we want to create the schedule at noon?" This was an example of confirmation. The third benefit is user correction. If you remember at that point, user replied with, "No, make it 9 a.m. instead." The user changed his mind here. Hence, it's user correction. And Alexa Conversations will support this without you having to create a new sample dialog. The fourth benefit is proactive offer. Alexa Conversations allows us to proactively offer an API. So if you feel that the user is always calling, say, show schedule API after creating the schedule, you can proactively offer to do so by saying something like, "Would you like to see the schedule?" The last benefit is interoperability. If you already have an Alexa skill and you want to extend it to use some of the features of Alexa Conversations, you can do so just like iRobot did.
I'm Angeliki, and I'm an Applied Science Manager at Alexa Natural Understanding. Today I'm going to go into a technical deep dive of Alexa Conversations. Let's start by the dialog simulator component. This is the component that adds more dialog variations in addition to the dialogs that developer writes. So these are additional synthetic dialogs that we generate that the developer does not have to write, and those dialogs typically may deviate from the happy path, or there are alternate paths that the dialog can take. Earlier, Nehal spoke about the built-in assets that the developers write while they're developing their skill. Those are the API references, the slots, the response templates, and the sample dialogs. All those are the input to the dialog simulator. The simulator generates dialog in 2 steps. In the first step, we simulate the different dialog flows, which are alternate paths a conversation can take. In the second step, we inject natural language variations into those dialogs. So those are different phrasings that a user can use in order to communicate with Alexa. For example, someone might say, "I want to watch a movie," or they might say, "Recommend me a movie." We generate those natural language variations through paraphrasing. And finally, after those 2 steps are complete, we are able to generate tens of thousands of training dialogues that we use to train the downstream conversational models. So let's go into more detail about how this works. For dialogue simulation, we consider goal-oriented dialogue as a game. In this game, the user has a goal, and Alexa has access to the APIs and the resources to help the user achieve their goal. So in this example, the user's goal is to find out about the weather, and Alexa has access to an API that can look up the weather in a particular location and a particular date. So this is a collaborative conversation where the conversation participants take turns and perform actions in order to achieve their goals. More specifically, the user progressively reveals their goal to Alexa, and Alexa gathers this information and asks for more follow-up questions in order to get information that may be missing in order to achieve their task. Using this framework, let's see how we would generate an example dialogue using the simulator. In this sample dialogue, the user starts by informing their goal, and in this case, the user says, "What's the weather?" From Alexa's side, this looks like calling the Get Weather API, and this API has two input arguments that are required, city name and date. So Alexa will go ahead and request the slot values for those input arguments, and will ask the user which city and for which date. In this simulation, the user informs back the slot values, they say Seattle today, and then Alexa goes ahead to confirm the information that the user gave. Finally, in the simulation, the user affirms, so they say yes. Alternatively, the user could have said no, or could have said yes to one of the slots and no to another one of the slots. And since here the user says yes, Alexa goes ahead and calls the APIs, get the API output arguments, and then informs those results back to the user. So presents to the user what is the weather in a particular location and a particular date. So this example was a happy path example. So in the dialogue, everything goes as expected. But we also simulate different alternate paths and different user behaviors. For example, you can see on the left-hand side a case where the user is more cooperative than expected. So initially, the user asks for the weather, and when Alexa requests the city, then the user responds by saying tomorrow in Seattle, so gives both the city and also the date. In this case, Alexa correctly understands that the date is already provided, so does not ask for the date again. In the middle example, you can see a case where the user is changing their mind. So the user initially asks for the weather in Seattle, and then Alexa proceeds to ask about the date, but the user changes their mind and asks for the weather in Boston. Alexa correctly understands the change of location and asks again for the date. And finally, in the rightmost example, you can see a case where the user is less cooperative. For example, when Alexa asks for city and for date, the user only provides the date, which is tomorrow, so Alexa has to ask again about the city. Here I gave examples of user behavior simulation, but we also simulate Alexa behaviors. So for example, we simulate Alexa proactively offering skill functionality that is related to what the user is currently doing. And we also simulate Alexa confirming slot values or APIs. Why is it important to simulate all those different dialogue paths? So as Justin mentioned earlier, there are many nonlinear dialogue paths that a conversation can take. And in real life, the skilled user might display these different behaviors and may take those paths. So we want to simulate those behaviors in advance in order to make the conversational models robust to such behaviors. And at the same time, we don't want to require the developers to do the extra effort to write those examples themselves. So now I'm going to go ahead and describe the conversational models that we use in Alexa Conversations. Those models are built using the latest deep learning techniques, so they ensure state-of-the-art performance to our users. The first model is the Named Entity Recognition Model, or NER. Earlier, Nehal referred to slots, which are defined by the developer and backed up by catalogs of slot values. The slots are units of information that need to be passed on to the API or to the response templates, for example, city or date. The NER model looks at the user utterances and extracts those slots from the user utterances. So for example, when the user says Seattle today, the NER model will recognize that Seattle is a city and today is a date. The second model that we use is the action prediction model. The action prediction model predicts what is the optimal next action that Alexa should take using the current user utterance as an input and also taking into account the whole dialogue history so far. So in this case, after the user says Seattle today, the action prediction model looks at this input and the whole conversation and predicts that the optimal thing to do is to confirm what the user just said. The action prediction model evaluates different alternative possible next actions, for example, possibly notifying the API response back to the user and select what is the optimal one, which in this case is to confirm. Finally, the last model we use is the argument filling model. The argument filling model fills in the values of the API input values and the response template input arguments by looking at the whole dialogue context so far. It does that by picking the values by looking at all the compatible slots from the slots that the NER model recognized earlier. So in this example, when the user said Seattle today, the NER model already recognized Seattle as a city and today as a date, and the action prediction model already decided that the best thing to do is to confirm. So the argument filling model now goes ahead and selects the value Seattle as the input value for the city argument and the value today as the input value for the date argument for the confirm template. So now the confirm template is complete. So after those two models are run, we make sure that their decisions are valid and compatible. So for example, we would never go ahead and call an API that has a required input argument if this input argument is empty. So this completes the technical deep dive. Thank you very much for listening. Now Justin will go ahead and share some resources to help you build skills with Alexa Conversations.
Okay, thank you, Angeliki. It's great to understand how Alexa Conversations works at a lower level. And so iRobot and Big Sky are excited to bring new experiences to their customers with Alexa Conversations. And we are also seeing excitement from tool providers. VoiceFlow, whose aim is to empower developers and designers to build quality video experiences easier and faster than ever, are very excited. CEO of VoiceFlow, Brandon Ream, thinks that Alexa Conversations represents a dramatic new voice development technology for their customers. So keep your browser locked on voiceflow.com so you'll know the minute they've integrated Alexa Conversations into their offering. And so as we draw to a close, I'd like to present you with a collection of assets to get you started on your Alexa Conversations learning journey. So be sure to take a screenshot of the next slide in 3, 2, 1. Did you get that? All right. So we currently have some fully functional reference skills available in the developer console. And so when you create an Alexa hosted skill, you can choose from one of 3 reference skills. And we have Hello World, WeatherBot, and Pet Match. We also have a step-by-step modular learning course designed to teach you the fundamentals of Alexa Conversations and to create the 5 build time assets that Nihal spoke about during her part of the presentation. We also have some reference skills available to you to look at on GitHub. So if you go to alexa.design/ac-GitHub, you can access the reference skills there. And while you're reading the tech docs, I encourage you to brainstorm about how you can use Alexa Conversations to open up new experiences to your customers. So with that, I want to thank Nihal, Angeliki, Nick, Stephen, Jeff, and Braden. And also thanks to all of you who are making Alexa smarter by building Alexa skills. Let's build the future of voice with Alexa Conversations. Thank you.